Our definition goes like this. Atmospheric pressure is the weight of the atmosphere acting on you. So when I go and I look at this guy, this is what I mean by this. And that shouldn't be too big of a surprise because look at how we defined weight. It's how much weight is acting over an area. So if I look at atmospheric pressure, it's the weight of the atmosphere doing this. And we need to sort of like imagine, what do I mean by atmospheric pressure? And so what I'll start here is that I'll make a ridiculous assertion and then just to get a sense of a number, and let's go from there. So what I'm going to do is that I'm going to say, to get a sense of this thing here, let's imagine a little green person. Holding boxes of air. So you could imagine that I have this little green person, and what they're going to do here is they're going to hold a box. So you could imagine that I come in here and we're going to be holding a box like this. Right? Here's our box. And what we know about this is a box of air is 2.75 pounds, but we're going to approximate this thing to 3 pounds, just because it makes it easier to deal with that. So this means that this person at this point is holding about 3 pounds. Now, what you could imagine here is that each box represents 1 meter of atmospheric pressure. That represents the air. So the question now is that how high is the atmosphere? And the answer is that it's 40 kilometers, which is equivalent to 40,000 meters. So 1 meter represents 3 pounds. So you could imagine that now I have a situation that, what do we do next? We go in here with our little guy, and what we're doing here is that now we're stacking more boxes. And as I stack more boxes, you could see that every time I stack a box, I'm really adding 3 pounds. So you could imagine 3 boxes is going to add up to what? 9 pounds. So in 3 meters, this person is holding 9 pounds. But wait a minute, the top of the atmosphere, right, is 40,000 meters. That means we need 40,000 boxes. So you could imagine here, now, if you want to weigh, you want to understand the weight of the atmosphere, we have to come in and we have to do what? This person would have to hold boxes that go all the way to the top of the atmosphere. And what we see here is that what we're really getting here is that from here to here, there has to be 40 40,000 boxes, which is about 100, was it 40,000 times 3 gives you 120,000 pounds. That is crazy. So let's be careful here now. So I said that that's a white lie. That's not true. Remember, the atmosphere thins out as we go higher in elevation. So if I was to just show you up here again, let's go back to our diagram. Look at that. As you go up, you could see that the air gets less dense as we go up. So this lie that I just do here has to be cleared up. So here's what you find out. The correct weight of the atmosphere is 40,000 boxes of air when you add 4, the thinning out of the atmosphere equals 22,500 pounds. You got to admit, that's a lot of weight of air. And if you convert this to newtons, this is 101,000 newtons. This is the weight of the atmosphere acting on you. And that is insane, right? This is insane amount of weight. You probably didn't realize that you had 22,000 pounds acting on you, right? Who would think that, right? Who would think that you would have that much weight acting on you? Not me. So what we want to do here is that we want to go in and we want to then define atmospheric pressure. So here we go. So what I'm going to do now is that I'm going to come in and I'm going to do the following thing. What you find here is that the definition of atmospheric pressure now, which is we define this as ATM for atmosphere. And if you look at this, PATM means ATM, the first 3 letters of atmosphere. So atmospheric pressure is then equal to the weight of the atmosphere divided by 1 meter squared. Okay, and so when you look at this thing, this is 101,000 newtons divided by meter squared, and this is what we write as 101,000 pascals, and that's PTM. That's what atmospheric pressure is.